This is a lecture on calculus, average value. Calculus, talking about average value. Now, let me give an example. Suppose you have 3 tests. The first test is 70%, 70. The second test is 80. The third test is 90. And the question is, what is your average grade? All right, you add the 3 numbers. So you add these 70, 80, 90, it's 240. And you want average. You have 3 tests, so you divide this number by 3. 240 divided by 3, you have 80. So your average grade is 80. So this is very easy to understand. Now you have a function. Let's have a function, f of x. Now, a function can be represented by a graph. So I have this, or something like that. Okay. And so let's use this to represent test 1 here, test number 1, test number 2, and test number 3. So test number 1 is 70. So I use this as 70. Test number 2 is 80. Okay, so 80 is here. So maybe my graph is not like that. So that's 80. Do you get me? So 90 is here. So forget about this graph. So it should be something like that. Okay. My graph should be something like that. Now, if you add these, so add these and divide by 3, don't you see that this looks like an area under the graph, under this graph, the area under this graph, and divided by this line, divided by this interval. So let's generalize the average value of a function. So the average value of a function. So now I can draw a function like that. What is the average value of this function on an interval x1 to x2? So the definition of average value is the area of this divided by the interval. So f of x, the average value of this is to integrate this function with respect to x from x1 to x2. That's the area. That's this area. And you divide this by x2 minus x1. And this is the definition of average value of a function. Okay. Now I have a calculus question. The question is, I am given a function 4x cosine x squared. What is the average? Average of this function on an interval from 0 to pi over 2. So this is my question. So from our discussion a moment ago, I want to find the area of this function between x equals 0 and x equals root pi over 2. So this is what I do. Integrate with respect to x. Divide by x2 minus x1. So this is my average value. So how do I do this? There are two ways of doing it. One way, the usual way, is to use integration by substitution. Let u equals x squared. Then du is 2x dx. This is called a differential. Then from this, I find dx. Dx is du divided by 2x. Now, my integration can be rewritten divided by, so I just copied the average value definition here, and I use substitution. Since my substitution, u is x squared, so therefore this is u. So this is equal to cosine u. And dx is du by 2x, du over 2x. So du over 2x divided by square root pi minus 0. Okay. See that the 2 and 4 cancels. I get a 2 here. And this x cancels this x. Therefore, I have 2 cosine u du divided by root, oh, I don't need to write minus 0. Okay, for the time being, I just write minus 0. So this is easily integrable. So I integrate this. I move the 2 outside. I integrate cosine u du. What is integration of cosine u? It's sine u, right? Okay. So this is my integration. And I need to put the upper limit and the lower limit. So what is the upper limit? The upper limit is root pi over 2. The lower limit is 0. So I can put the upper limit here, lower limit, upper limit, lower limit. Oh, just a moment. Here I integrate with respect to x. Therefore, my upper limit and lower limit are the limits on the interval of x. But now I changed my variable from x to u. Therefore, you cannot write 0 and root pi over 2 because I need upper limit and lower limit for the variable u. For the time being, you just leave it blank. So I need upper limit here and a lower limit. Now, the upper limit of x is square root pi over 2. But I need the upper limit for u here. So in general, I want u1 and u2 like this. But let's not do this. Let's change the u back to x. All right, change the u back to x. What is u? That's x squared. Now, I can use the limit, upper limit and lower limit for x now. So it's 0 root pi over 2. What is this? Or maybe I can write here. So this is 2 sine x has to be squared, so that becomes pi over 2. And you subtract, put 0 in. What is sine 0? Sine 0 is 0. I need a bracket here. So this is just 0. So what I have is 2 sine pi over 2 over square root pi over 2. What is sine pi over 2? It's 1, is it? So let me see. This is 1, so it's 2 over pi over 2. Then if I simplify this fraction, then I have 2. You flip this, 2. So this is my answer. Any questions? This is my answer. However, I do not like substitution in this case. What I want to suggest is differential. Let me start from here now. Factor out a 2 in front. Then I have 2x, right? I use a trick. I write this first, cosine x squared. Remember, I have 2x here. So I write 2x dx. To make everything clearer, I put a bracket here. And then the denominator is simple. Now, remember, to do this way, I want you to be very good at differential. 2x dx. If you look at this, you should immediately see this is dx squared. So I rewrite it. This is dx squared because dx squared is 2x dx. That's why I said if you are very good at differential, then you can do this way. Once you have this way, look. So next step is very simple. Because this is the same as that. So the integration of this function is just sine x squared. So I have immediately sine x squared. What I'm doing here is essentially the substitution, but I write it simply using this idea of differential. Then once you have this, you put upper limit and lower limit, and blah, blah, blah. So I don't need to repeat. This is what you have here. So same thing here. Understand? Okay, so this is an example of average value using substitution, and compare my way, which is using differential. I believe using differential, the writing is simpler. It's shorter and simpler. But the idea is exactly the same. Thank you for watching. See you next time. And remember, if you have any questions, just message me using this telephone number. You can ask any questions at the level of university first year calculus, or high school grade 12 calculus and vectors, advanced functions, as well as physics. Okay, physics. I do physics grade 12 and university year 1. Thank you for watching. Goodbye.